Well, my name's Peter Webster. I was station manager here in the late 1990s, 95 to 98, and we're currently standing in the main control room of Oldbury Power Station. I enjoyed it very much. I do admire the technology. I admire the control that goes into it, and I find it very interesting. And there was a degree of passion about the people who chose to work in this industry, and the level of commitment, the level of interest, and the level of expertise I thought was just, it was good to be associated with. It's putting to use that raw material, the uranium, for which there's very little other use in nature. It's a naturally occurring element, and be able to get electricity, power from that material through the processes that mankind has devised, I think is fantastic. And the degree of sort of control that's built into nuclear power plants that is very refined, and they are essentially big pieces of equipment. They're big toys. There's a lot of things that form part of the power station itself, and I just found that I continue to find them really very interesting. Well, we're obviously inside the Oldbury Power Station reactor block, and we're standing on top of one of the reactors on what we call the pile cap, which is essentially the top of the main reactor core itself. It's the area from which the reactor is accessed to refuel, and around us we can see the big fueling gantries and the fueling machinery which were used to routinely change the fuel. Well, the reactor, of course, is the source of heat for the power station, and inside this core, all of the nuclear fuel is sitting there, and also inside the space is the carbon dioxide gas, which is used to take the heat away from the fuel rods. And also inside this space are the boilers, the heat exchangers. So you can imagine this is the unit that essentially produces the steam, which turns the steam turbines, which we'll look at elsewhere. But in terms of what you can see going on up here, you could see very little. Unless the plant was refueling, this is what it looked like. It was calm, reasonably quiet, and as I say, a little warmer. The gas is circulated round. The gas is at quite a high pressure, and it's circulated round inside the core by some large steam-driven gas circulators, which are elsewhere down in the reactor hall, well below us. And there are some pipes which you can't see from here, which basically bring feed water into the boilers. That's turned into steam by the heat in the reactor, and the steam then goes off and turns the steam turbine generators round and ends up generating electricity. The fuel does need changing from time to time, and this type of reactor, the Magnox reactor, is one of the very few in the world that's able to change that fuel while the reactor's at power, essentially on-load refueling, we called it. Where I am now is on the top of the central block between the two reactors. And this essentially is the top of a lot of tubes that go down into various facilities. And I won't describe them in detail, but essentially through some of these, the fueling machine gets its new fuel and it discharges the used fuel. Essentially these holes are sometimes go all the way down to the cooling ponds where the fuel is kept. Sometimes they're just storage tubes. Some of them are used for maintenance on things like control rods. There's lots of different access ports here to different facilities, and all used in the process of either maintaining the equipment like the control rods, or essentially changing the fuel. So behind me here is one of the fueling machines. As you can see, it's got a big B on it. That's because it's fueling machine Bravo. There are two fueling machines here, and you can see from the size and scale of it that it is a huge beast. It's very heavy. it's manoeuvred around on these gantries across both reactors. It can access both reactors. But this is essentially its parking position where it rests when it's not being used. And underneath me are the standpipes that give access to the core and the fuel and all the other stuff. But essentially, this is the top of the reactor I'm standing on now. So this big fueling machinery comes along and positions itself above one of these standpipes, underneath one of these square slabs, and connects up to it and accesses the core. Before the fueling machinery gets here, it picks up a number of new fuel elements from the store. Essentially loads itself up with new fuel elements. It comes over here with those new fuel elements on board. Having connected itself up to the reactor, there's a large sort of I'll call it a grab that goes down into a particular channel, and it picks up the 8 elements one by one. It latches onto the top of each element, pulls it up, puts it into the core, and does it with the other 7. So it picks all 8 out of that particular channel, and then it takes the new fuel, which it's brought with it, and reloads those back one at a time into that channel. And then when it's finished, it seals itself up again, seals the reactor up, and goes away to do something else. But that's the process in essence. We're now in the gas circulator hall. This is the ground floor now we're at in the building. Behind me, you can see the main curve of one of the reactors, and this is reactor 2, the outside of the concrete shielding. Behind me here, we have one of the 4 steam-driven gas circulators, and these are essentially large fans inside the inside the inner space of the core, which circulate the gas round and takes the heat away from the hot fuel elements and converts the water in the boilers into steam. So these are the circulating fans. There's lots and lots of pipes and bits of equipment and pumps around here, and most of those are here to support this turbo turbine. They provide the lubricating oil, they provide the oil for the operating valves and all the coolers and those kind of things. Well, we're now in the main turbine hall, and you can see there are 2 turbines here, one this end, one that end, and each of those was connected to one of the reactors. They're a multi-cylinder turbine, and on the end of which is the electrical generator. There's lots and lots of equipment in the basement here, all feed heaters and steam pipe work and water pipe work and electric pumps and oil systems and all of the complex array of equipment that's needed to support these turbo generators. They rotated at 1,500 RPM. They're 1,500 RPM machines. In its heyday, when this plant was operating, this room would be noisier. You wouldn't be able to have the conversation we're having now, quite a lot of noise. It would be hot. They were very warm plants, and they, particularly in summer, the buildings did get very warm. It does look much as it did. You can see some of the paintwork is starting to peel a little bit on the colder materials. It looked much smarter than this when it was generating. Very limited number of controls down here. You can just see a few dials on these panels, essentially monitoring various things. But all of the primary controls were up in the main control room. Well, this room is the main control room, and as the name suggests, this is where everything is controlled from. There are a lot of controls in this room and a lot of indications, because to support sort of safe, reliable operation of a reactor and the sort of ancillary equipment, the turbines and the other things you need to end up with electricity coming out the end of the process. There's a lot of systems there to support all that. There's sort of oil systems and water systems and gas systems and lots of indications in here of the condition of those particular systems, the pressures, the temperatures, what's happening in them, and the ability to open and close valves and to put settings into controllers from up here. So essentially this did run the reactor and all of its equipment. One of the things they built into this kind of plant was, we call it redundancy, but it's essentially to ensure that the plant can continue running. We put in a number of each particular pump so that you could take out one pump if it developed a fault or you wanted to do routine maintenance on it, and still keep the plant running. You didn't have to shut it down just because one pump needed a little bit of work on it. So there's multiples of a number of sort of the features and facilities here. That's why there's so much around. It's important when running these reactors that you're absolutely confident the things will remain under control, will remain safe, and will safely shut down if they need to. Safety is always uppermost in our thinking, actually, in a place like this, because we know that our primary task is to generate electricity from these reactors. But the overriding requirement is to make sure the reactors are themselves safe. This technology is such that you do need to ensure that the radioactive material is contained, is controlled, and a lot of these systems are there to do that. It's not been unusual to find people do a number of decades working in these plants. I enjoyed being part of that team, actually. It felt a bit like a sort of ship, and you have the privilege of coming aboard as captain, and it was a plant that worked very well. It performed very well, very consistent, very reliably. It was a very safe place to work, and it had a very a hard one, but a very good record, and it was something to be proud of. We did what we were here for, and that was generated electricity 24 hours a day, reliably, safely, and that was our job, and we were proud of it.